Okay, this is a little demonstration of how the R group, and specifically the polarity of the R group, affects the structure of a protein. This is my polypeptide chain here. It's made of my amino acids, which are my little bits of sticker. And so this is basically what a polypeptide chain is. Now, a protein can be made of either one or more polypeptide chains. So it's just a string of amino acids. And you've probably already studied the structure of amino acids, so you know that it's made of four functional groups around a central carbon. The key functional group that I'm going to focus on for this video is the R group. Now, the R group can either be polar or non-polar, and that's where I'm going to make a distinction here, which my pen might not work, which means, okay, that's not going to work. Can you see that? I hope you can see that. Ah, there we go. Okay, so if I mark a piece of sticker, that means that that R group is polar. So I'm just going to do some random ones here. Okay, so let's say this amino acid has 3 R groups which are polar. Sorry, that's my dog scratching at the door. Okay, so these 3 groups are polar. Now, what happens when molecules are polar is that they form hydrogen bonds, and this is what affects the shape of the protein. So you're going to have hydrogen bonds form here, or you might have another hydrogen bond form here, and then that one sticks out like that. So this might be one shape for the protein. Maybe the hydrogen bond forms here, depending on how it's folded. So you can see the shape has changed, right? Now, if I add, let's say I add another one. There's another one with a polar bond, and here's another one with a polar bond. So now you have more polar R groups on the amino acids. The other amino acids haven't changed, but now you can see how the shape might change again. Maybe there's a bond here. Maybe there's a bond there, which brings it closer together, and then these kind of stick off in the distance. But I'm hoping that you can understand that the polarity or non-polarity of each of the R groups is going to change the shape of the protein. And so then if you think each protein contains thousands and thousands of amino acid chains, then you can see how this might also change. Let's say if I make that a non-polar group, I'll just turn that over. Now you don't have that end of the chain being folded, so you might have that fold there and a hydrogen bond fold here, and then maybe a hydrogen bond forms there. The point is that the R group and the polarity of the R group is going to determine how the protein folds and therefore determine the protein shape. And I'm going to do a different video explaining why that matters.